Good morning. My name is Mackenzie Vadis, and for my lab experiment 6, I will be going over how to find theoretical yield and percent yield based on a practice problem I have provided. Our practice problem is, what is the percent yield if 13.24 grams of aluminum is recovered when 0.815 grams of aluminum were used for the reaction? So what our math will look like for this one is 0.815 grams of aluminum were used, multiplied by 1 mole of aluminum divided by 26.98 grams, and that 26.98 grams comes from the periodic table. The mass of aluminum is 26.98, and we are going to multiply this by 2 moles of alum divided by 2 mole of aluminum multiplied by 474.46 grams of alum divided by 1 mole of alum. Now this 474.46 is the mass of the potassium alum, so that would have been found by adding all the masses of potassium, aluminum, sulfur, and oxygen. That's from the sulfate and the 12H2O that made this alum. And when we do the math, this is what we get. So because there are 4 sig figs, we are going to round to 14.33 grams, 14.33 grams of alum. So the next thing we are asked to find is the percent yield. So the percent yield would be the actual amount divided by the theoretical amount. So from our problem, we know that the actual amount was 13.24 grams of alum, and that will be divided by the theoretical yield, which was 14.33 grams of alum. 0.33 grams of alum, and we will multiply this by 100. So in the calculator, this looks like 13.24 divided by 14.33 equals 0.92 multiplied by 100. We get 92.39%. So that would give us 92.39%. Now, the reason why we have to divide actual grams by theoretical grams is because the actual amount is calculated after the experiment from the results that you received, but the theoretical yield is calculated before the experiment, and it assumes that everything in the experiment will go perfectly, so we never really get to the theoretical grams because there are always some factor like not reacting completely or something of that nature, so that's why normally the actual grams is less than the theoretical grams. But in a different case, what would it mean if the percentage is over 100%? So let's just reverse the theoretical and actual grams. So let's say for our actual, we got 14.33 grams of alum. And for our theoretical, we got 13.24 grams of alum. So if we were to show this in the calculator, we would do 14.33 divided by 13.24, enter, multiply by 100. So that gives us 108%. So that would be 108.23, or because we have to keep 4 sig figs, 108.2%. Now this 108 shows that there have been other reactions or some kind of impurity involved in the experiment. So for this, we could say that it possibly had plastic residue left over from the aluminum used, or there was residue in a beaker from a previous experiment, but all this number means is there was some additional factor in the experiment and it was not pure. Thank you for watching and have a nice day.